Hello and welcome to my channel Linux World. Today we're going to talk about Linux LVM, logical volume partitions, in continuation with our managing disks on Red Hat 9. In the last videos we have used the fdisk utilities to partition the disks. So let's take a look at our disks on our VM37, LSBLK. And the third disk we worked with was SDC. It seems like it has 5 partitions, and the first one is used on my DB01 file system. Okay, let's look at another command, df-th, and you can see that my DB01 is in fact in use. It has a XFS file system on SDC1. So we have SDC 2, 3, 4, and 5 to use. They're 1 gig each, so that's fine. So now let's talk about logical volume management, LVM, right? So let me start with a diagram here to give a short overview or concept of what that is. It looks like so LVM in Linux. And we will go to images and see if we can find a basic diagram. This looks good. Now let me click on this. So here it is. So we have these. If you look at this diagram, the bottom, let's start with the bottom. There's physical volume. These are physical disks, and then there's a volume group that has 3 physical disks assigned to it. So that's then you have 2 logical volumes. So LVM is logical volume management. Basically, you're creating logical disks, and the underlying hardware is physical disks. And the you could have multiple. You could take, like, let's say this is 100 gigs each disk. You 3 disks. You're combining it, creating one pool, like volume group. And then out of that you're creating disks, and then on this disk you will mount the file system like /app1 /app2. So this is the basic of it. So first thing we're going to create is a physical volume out of the physical disk, and then we're going to create a volume group and then logical volume. So let's look at this in action. We can understand more and more about it as we do it. So okay, so now that we run the lsblk command, SDC1 is in use. So first thing I want to mention is, let's say /db -ts/my DB01 file system. You can see that it's mounted on SDC1 and has 1 gig in size. So let's say this /my DB01 gets full. It's only 5% used, and let's say it's 100%. I cannot extend the disk size of SDC1. I cannot assign SDC2 and combine these two together to extend the size of this file system. Now, so let's say the database guys or whoever, the app1, let's take this one for instance, app1. Okay, so df-th app1, and let's say this gets full. Same thing with this. I cannot extend this. So one of the benefits of logical volume management is you can resize your logical volume on the fly dynamically, extend the disk size on the back end, and resize them basically, right? So it's always the best option to use logical volume management when you can. Okay, just like if you look up here on an SDA system, my file system is laid out like the whole file system of Linux. /boot is on a separate partition. It has all the boot files for Linux, but / is a logical volume management here on SDA2. And if I want to extend this, I can easily extend that. We will look at that in detail. So first thing first is let's start with taking a raw disk and creating logical volume management on it. So we can use SDC2. So first thing we do is, if the first command, and when we look at that diagram, first thing we want to create is tell the system it's a physical volume. So if I do PVS, which stands for PV scan, physical volume scan, or you can do PV display. Okay, shows you a different output. You have one PV. Basically, SDA2 here is used with logical volume management. Okay, it gives you some information. PV scan tells you the PV is SDA2, and inside it we have a VG volume group called root VG. Okay, so that's PVS and PV display, and you could do fdisk minus L on SDA /dev/SDA. You can see that the SDA2, like the PV is defined here, you can see in here the raw disk SDA2 is a Linux LVM type. Okay, so we have used 3 different commands to identify that. Okay, so now we will use let's go back and do lsblk. We'll use SDC2. So I will do PV create /dev/SDC2. So first thing first, we have to tell the system that this is a physical volume, and once you run this command, the system will know that this is going to be used for logical volume management. So like it says physical volume created successfully. So we do PV scan again. I like this command because it's nice and short. You just want to see which physical volumes that are defined on the system. Okay, so there you go. SDC2 is part of it. There is no volume group on it. So we're going to create a VG. VG create our test VG. We're going to name it. And we're going to create it on dev/SDC2. Okay, and that's how you create it. Successfully created. Now if you go up and run PV scan, you can see that SDC2 now belongs to test VG. So we created the physical volume, then we created volume group. We could do VGS to VG scan. It gives you a different, the first thing output that it's going to show is we have 2 VGs, root VG and test VG, and the PV, it has one, root VG has 1 PV and 5 logical volumes, and this one has 1 PV and has 0 logical volumes. Okay, and this is the size. Okay, let's clear the screen out. PV scan, we have created 1 PV that has a test VG. Then now let's create a logical volume. Okay, so now we want to create this for, let's say, some app, right? Application like JBoss, for instance. Okay, so or test, we're gonna call it test LV at this point. So we're gonna click LV create. We're gonna give it minus name test LV logical volume, and we're gonna minus for to specify the size. We're gonna say minus L, and we want to use the whole all the space inside this volume group, which is only 1 gig at this point. So to do that, if we do minus L 1 GB and then define test VG, it will show you that the volume group test VG has insufficient space. So to use, you could go a little bit below 1 gig, or you could use this command, LV create minus n test LV and minus L to specify the size with plus 100% free, like so. Okay, and under test VG can parse argument minus size plus. Oh, I mean, I have to probably give it a space here, like that. Invalid argument. I may have to use a different flag. I think with this option you have to use a lowercase l. There you go. Yeah, lowercase l, or you could use minus size. Okay, I think minus size is pretty good. So we have already created that logical volume test LV created. Now if you do LVS, you can see that our test LV is as part of the test VG and has 120, about 1 gig, right? So that's one way to look at it. So let's clear the screen out. PV scan. PV shows that we have 2 PVs. SDC2 has 1 VG, test VG inside it. VG scan will show that a test VG has one PV. We looked at it here, and has one LV, and we can do LV scan and see that test LV belongs to test VG, and it has this much size. It's taking all the volume group size. Okay, now so we have this final product, which is the logical volume, right? So if you look at that diagram again, let's go look at that diagram again. It's over here maybe somewhere. No. Okay, let me reopen my page here. Look at the diagram again. Okay. Linux LVM and images, and I like this one. So we have our final product. Instead of using the physical disk and laying the file system directly on it and mounting it to a mount point, we have now created one disk. We have created a volume group, and then we have a logical volume. And now at this point, what we can do is we can make a file system, mkfs minus type xfs file system on this dev. The whole path is dev test VG and test LV. So this, you have to define it like so, and the file system is created. Now let's create another directory, mkdir slash, let's say, app3. Okay, and then mount this app mount slash dev slash test VG test LV and app3. Okay, fs tab has been modified, but the system still uses the old version. Use systemctl daemon reload. Okay, we will do that in a minute. And df minus th will show that now we have app3. Just like app 1 and app 2, we have now app 3 mounted to a specific disk, which is with this the whole actual path. We can give it a short path, which is the dev test VG test LV. The actual path is dev mapper test VG test LV, but in the df minus th command output, it has a hyphen between the VG volume group and the logical volume. Okay, it shows it's XFS. And app3 is mounted on it. Another, we could do lsblk as well. I love this command because now you can see that in SDC we have SDC2. Underneath that we can see the mapping. Test VG and test LV, which is mounted on app3. Now if we reboot the system, this will get unmounted, so we have to make an entry in fs tab, etc fs tab, file system tab directory, go down, and to write this, you can copy logical volume like that stuff up there, dev mapper, it's test VG hyphen test LV, and it's mounted on app3, and the rest of the stuff is same. XFS tab, I can use tab, and you don't have to write it directly underneath the above lines. Defaults and the rest of the stuff is same, 0 space 0. So default is we are not specifying any options on this file system, like mounted with the read write or these certain permissions, and there are a lot of options available. And then 00 means we're not gonna check this. We don't have any file system checks when you reboot the system, or periodic file system checks. Okay, so we're gonna write that in just to make sure that our entry is correct. We're gonna mount minus all. When you run this command, it will remount. It will mount all the file systems mentioned in fs tab. It will remount, and if there is an error in your syntax, it will tell you here. So now, if we reboot the system, my app3 will get remounted or mounted as part of the boot process. So looking at this diagram again, we have created a, I keep losing my tab here, let me bring that up again. Okay, LVM, we go to images. So let's look at this one first. It says, so we have used a disk, okay, and we have defined a volume group, and we have mounted it. Okay, maybe that's not a good diagram, but Yeah, we are mounted it. So now let's go back to the terminal, and let's say now that my app 3 is full. Okay, instead of 5% usage, they're at 100%, and they're saying, hey, we need more space. Unlike the other two that we cannot extend with logical volume management, we can with this. So let's say, how are we going to do that? Okay, you get a ticket, hey, extend this app 3 or extend this app. So you go look at that, it's mounted on app 3. You know that, you talk to them that our data is under /app 3. You use df-ts to look at it. You know that it belongs to test LV and then the whole path. So now the first command I would run is to extend this. Is I would see if there's already space available on my volume group, okay, which is test VG. So I would do VG scan, and I see that there's 0 free inside test VG. So now I automatically know that I need to add a physical volume to this. Okay, it has one physical volume and it has one volume group and has no space. If there was space inside the volume group, I could have run LV extend command to extend the existing LV. But in this case, we only have one PV assigned to this, so we will add another PV. So the second thing I'm going to look at is I'm going to run lsblk to list out my block devices to see if I have another physical disk available in the system to assign it to this volume group. So I do. I have SDC3. I'm going to use it. You can either go assign another disk like SD D, ABCD, or you can just use this partition we already have. So since we have that, we're going to do, instead of PV create and all that, I can just directly use, we know that first we have to do a PV create, define a physical volume, then extend the volume group. So we'll just do VG extend. I'll just type V. If you type VG and press tab, you will get all the commands starting with VG. So what we want to do is VG export, display, all this. What we want to do is VG extend right here. So VG ext, and then I'll press tab again. I want to extend my test VG, and I want to extend it to /dev/SDC3 here, right here. Okay, SDC3. And you said physical volume. What it does is it automatically creates, defines SDC3 as a physical volume, and then it extends the volume group test VG as well in a single command. So now if you do VGS, you will see that it will have 2 PVs, okay, and has about 1 gig free. Now I know. So I do LVS. My test LV, it belongs to test VG, and I will do LV extend command. Now there's 2 ways to do it. First, you can extend your logical volume, okay, and then if you look at here, this will not get extended. The whole size of this is about 1 gig, right? The app 3, you have to first run a command to extend the volume, and then you have to run another command to extend the XFS file system. To do this in one single command, you could do this LV extend. Always remember, LV, when you're doing commands with LV, it's going to be different than PV and VG. LV extend, we're going to extend, you have to give the full path, test VG, test LV, and we are going to specify here -R for recursively extend this, meaning extend the logical volume, also extend this file system. Okay, I'll be extend -R, okay, and we're going to specify -L plus, same thing, use whatever is left over. If you want to specify a specific size, you could do capital L and say use only 500 megabytes, right? But I want to use the whole disk SDC3 that we have assigned to the volume group, right? So I'll do plus 100%. So we will do this 100% free. Okay, minus size. Oh, we have to use a minus size. Okay, you have to use a lowercase l to do that. Okay, so and the same command, it extended and it grew the XFS file system. So if you do df-th again, you see that this file system has a size of 2 gigs now. Okay, it still belongs to test LV. If you do LV scan, you can see that LV is 2 gigs. You can do PV scan. You can see that you have 3 PVs here. STC2 and STC3 belong to same volume group. VG scan will show you that you have 2 PVs belonging to test VG. So this is how you can easily extend the file system, and in the future, if it keeps growing, you can keep extending it. So let's say we will just now delete this. So to delete the process, you have to do everything in reverse. First, we had created the physical volume and volume group in a single command. Then we created logical volume. Then we defined the file system, and then we mounted it on app3. So first thing we will do is we'll go in reverse. We will unmount. And we will take the entry out of etcfs tab so it doesn't try to mount it. Shift G to go to the bottom of the line and press DD twice. DD. WQ bang. Right, and quit my changes. Okay, and then umount / my app3. Okay, umount my app3 was it? Okay, let's do app3. Umount app3. Okay, so do df, and it's not there anymore. Okay, so then after that we will delete you can delete the LV and then delete the PV VG. What I could do is VG tap. I can just delete the VG. It will delete all the LVs if it has multiple LVs inside it in the single command. So VG remove. You can see that VG remove test VG, and it asks you a question. Do you really want to remove the volume group test VG containing 1 logical volumes? Yes. Do you really want to remove the active logical volume test VG test LV? Yes. So in a single command I was able to remove my volume group and logical volume, and if I do VGS, I only see, and it's not there anymore, LVS, test LV, and test VG is gone. I don't see my test LV here. I don't see the VG, but PVS will still show you that STC2 and STC3 are still defined as physical volumes. We can do now PV remove /def /STC2 and /def /STC3. Okay, wiped. So if I do PV scan, it's not there anymore, and the disks are ready to be reused as however you want. So that's it for this video. We're gonna do some more things in the LVM part in the future. Thanks for watching. Stay tuned.